Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about solving log or logarithmic. Log is kind of the shorthand way to say it. Solving log equations. Within this, we're going to keep one thing in mind, that when we do get our answers, we're always going to check for extraneous solutions. I'll show you. Extraneous solutions are kind of like extra solutions that don't actually work. You'll see that at the end of each problem, we're going to check to see if the solutions actually will work. So notice what we have here. Log base 2 of 5x minus 10 equals log base 2 of 4x plus 1. So hopefully you notice that on either side of that equation, we have a log base 2. When that happens, and that's the ideal situation, is we really want, those are going to be the easiest problems, when we have a log with the same base on either side of the equation, because what we can do is this. And it's kind of like they get canceled out because we've got them on both sides. So then once we cancel those like log bases out, then all we have left is this 5x minus 10 equals 4x plus 1. So let's rewrite that. So now at this point, we just want to solve for x. So we've been doing problems like this forever. We would want to get our x's to one side of the equation. So I'm going to do that by taking the smaller x and bringing it to the larger x through inverse operations. So in this case, we're going to subtract 4x. And if I do that to one side, of course, I have to do it to the other side. Subtract 4x. So 5x minus 4x is just 1x, or we would just write that as x, minus 10 equals positive 1. So x is almost alone. I just have this minus 10 hanging out with it, so I need to do the inverse here to get it to the other side. So I'm going to add 10, add 10. So I get x equals 1 plus 10 is 11. So I'm getting an answer of x equals 11. Now, I'm not going to actually box that, call it an answer, and keep moving yet. We have to check for an extraneous solution. So we need to see, does 11 actually work when we plug it back in? And we're going to use the calculator to really help us do this. So I'm going to cut the calculator on. And I'm going to type in these two, so I'm going to bring back, I'm going to like uncross out my log base 2, and I'm going to retype in this equation, I'm going to get an answer, and then I'm going to type in this equation, and then make sure my answers line up. To type in a log function on the calculator, we hit math, alpha, math, and that'll pull up that log base function. So we would put in the base place, we'd put our 2. And then our parentheses, we're going to put 5 times, and it was x, but now it's 11. So we'll put 5 times 11, and then minus 10. Right? And then we'll see what our answer is. Now, we didn't get an error or anything, so that's good. It gave us an answer. We're going to do the same thing on the other side. We're going to type in math, alpha, math. We're going to type in log base 2, and this time we're going to use this one. So 4 times 11 plus 1. And we didn't get an error, which is good. We got the exact same answer for both of those. So this solution does check, okay? So now at this point, I not only box it, I do a little check mark. And that's just letting myself or whoever's grading my paper know, hey, I double checked and it is a solution. All right, let's look at our second example. In this one, hopefully you'll notice that we've got log base 4 of 4x minus 8 equals log base 4 of negative 2x. So that's a really good situation. Notice on both sides of the equal sign, I have a log and I have a base 4, okay? Best case scenario. Okay, so now that I've crossed those out, all I have left is 4x minus 8 equals negative 2x. And now I want to go ahead and use my algebra rules to actually solve for x. So remember, I want to take my smaller x and move it over to the larger x through inverse. 2x. And then we've got 4x plus 2x, which is 6x. We will bring down our negative 8. And we ask ourselves, what do we have left on this side? Well, we canceled out our inverse, so we just have a 0. That's okay to just have 0 on one side of the equation. That happens. All right, and then we would want to add 8. Add 8. And we get 6x equals positive 8. And then we're going to divide out the 6. And x equals 8 over 6, which does reduce to 4 over 3. First thing I know people are wondering is it okay to get a fraction? Absolutely. Okay, you can get a fraction, not a big deal. And a fraction can absolutely be a genuine solution to a log function. But before I box this and move on, I do need to check it to make sure, does this work? Is this a true solution? To do that, I'm going to use the calculator to help me. I'm going to bring that out. And I'm going to type in this into my first log function, and we're going to see what happens. All right, so let's start by hitting our alpha math. That brings up our log. Log base 4 of 4 times x. So this is 4 times 4/3, because we now know x is 4/3. So anytime I use a fraction, I always use parentheses. So that's 4 times 4/3 minus 8. And let's see what we get. Oh, okay. So we got an error, and it says non-real answer. What that tells me is this is going to be an extraneous solution in this case. Okay, so this is not going to be a real answer for the solution. And we could check the other side too, just for fun. Let's check this side too and just see what happens. So if I put math alpha math, and I type in log base 4 of negative 2 times 4/3, right? And I again get error, non-real answer. Okay, but honestly, I showed you both just because I wanted to make a point. However, if you do one and you get that error, non-real answer, and you know you've typed it in right, so definitely double check, but we definitely have typed it in right, you can stop there. You don't have to check the other side. If one does not work, it does not work. In this case, what this means is that x equals 4 over 3 is not a real answer. So I like to mark that just by putting a big X by it, and then I would put no real solution, and in this case we're just going to put no solution and S and box that. That's going to be our answer. I know there are some students that are going to jump to the assumption anytime I have a fraction, it's no solution, and that's just not true. Don't make that jump. This one just so happened to be a fraction, and we got no solution. Okay, it is perfectly okay to have a fraction, and plenty of times it will work out. So another thing I want to look at is why this one doesn't work out. Because if we were to manually plug in 4 over 3 just right up here, like let's forget the log base 4, let's just do this part right here. So negative 2 times 4 over 3. And do you notice that we get a negative answer? So this in the parentheses cannot be negative. We can't have a negative log and get a real solution. So just keep that in mind. That's truly why that doesn't work out. You should be able to plug this into this part and get a positive number. And the same thing happens over here. So if I were to test this side, 4 times 4/3 minus 8. I didn't even put the log part in. I'm just testing this, and notice, and again, we get the same answer, but it's a negative. Okay, so again, a negative number in here is no-go for a real solution. So we mark this one as no solution, and we keep moving. All right, let's look at some more examples. When we look at this third example, I know that looks like a lot. There is a lot going on there, and you would be right, okay? So let's kind of make some observations about this problem, because it does look different in a lot of ways from the last two we just did. What you hopefully will notice is that on either side of the equation, we do have a log base of 2, right? Log base 2, log base 2. The problem is that we have 2 of them over here. There are 2 log base 2's on this side of the equal sign. We've got a log base 2 and a 2x to the 5th plus 10x to the 4th, and then we are subtracting a log base 2 2x cubed. So this goes back into our expanding and condensing logs. If you are not quite sure what I'm saying when I'm saying expanding and condensing, you are going to want to stop and watch it's called properties of log functions or properties of logarithmic functions video. You're going to want to stop and review that first. All right, so when we see that on the left side of this equation, we got to take care of this before we are worried about solving the log. Hopefully you remember from that video or the previous lesson or just your previous knowledge that anytime we are subtracting logs of the same base, that really means we're dividing this part and this part, okay? So we can condense this by rewriting it log base 2. We're just writing it once. And then we're going to take this part, our 2x to the 5th plus 10x to the 4th. 2x to the 5th plus 10x to the 4th. And we are going to divide it by 2x cubed. Okay, and that is what's in our parentheses. And then over here on the right side of the equation, we still just have log base 2 of 14. We haven't done anything with that yet. At this point, we would want to reduce anything that we can. Hopefully you notice that within those parentheses, I've got some like terms that I can definitely combine through division to go ahead and simplify this all the way. So I'm going to keep, for this step, I'm going to keep that log base 2, and let's actually simplify this. So 2 divided by 2 is a positive 1. And x to the 5th divided by x to the 3rd, that's actually an x squared, okay? Now, if you were like, what did you just do there? How did you get x squared out of that? You're going to want to stop and review my video on dividing with exponents. So just as a brief reminder, when we divide with exponents, we subtract the exponents. So the base stays the same, the exponents subtract top to bottom. So 5 minus 3 is 2. If you need to, review that video. All right, now we'll move on to the second term. So positive 10x to the 4th divided by 2x cubed. Well, 10 divided by 2 is a positive 5. And x to the 4th divided by x to the 3rd is just an x. All right, and then again, we still have this log base 2 of 14. Nothing changed over there yet. Okay, so at this point, I have what was in my parentheses condensed, simplified as much as I can. And at this point, this looks kind of like the ones we just did on the first page, right? We have a log on either side with a base of 2. So we can go ahead and cancel out the log base 2. So now all I have left is x squared plus 5x equals 14. Hopefully this is looking a little familiar to you. This is reaching back into now, or we're incorporating into this our factoring. Okay, so hopefully you notice at this point we've got a quadratic equation happening here. I know it's quadratic because it's to the power of 2. My highest degree is 2, my highest exponent. When we have a quadratic equation, we could solve it through using the quadratic formula. We could use just traditional factoring, and that's what I'm going to do in this video. I'm just going to use traditional factoring using, I like to use the x to do it, so that's what I'm going to solve here, because I know it's going to work out to 2 nice whole even numbers, so that's what I'm going to go with. When I do any kind of traditional factoring, I always want to have an equals 0. I can't really do anything until I do have that. So in this case, I need to move this 14 over to the other side. And I'm going to do that using my inverse operations. So subtract 14 from both sides. And notice there's no like terms here, so I can't combine. That's okay. I will just bring down and put my constant, my negative 14, on the end. Now I have an equal 0. So once I have that equal 0, I'm good to factor. So again, I'm just going to use my traditional x method of factoring. So we need to label what's my a, what's my b, and what's my c. My a would be a positive 1. There's an understood 1 out here. My b would be a 5, right there, positive 5. And my c would be a negative 14. So remember, we build our x, our big X, and our a times c goes at the top, our b goes at the bottom. So our a times our c is a negative 14, and our b is 5. I always like to figure out my signs before I figure out my values. So what multiplies to give me a negative and adds to give me a positive? So hopefully you're thinking a negative and a positive. That would be the only way we could multiply and end up with a negative. So I know I need a negative and I need a positive. And then I've got to think, what multiplies to give me negative 14 and would add to give me 5? If you're ever unsure, you can always use it. If you're like, I have no idea what goes into 14, there's always a trick on the calculator. There's lots of tricks on the calculator that I have. The trick I like to use is going to y equals and doing the number we need, 14. Now you may be thinking, oh no, she meant to put negative 14. I always just put the positive version in. That's just me. You can put negative 14 if you want, divided by x. Look at our table. Okay, so I know 1 and 14 work, 2 and 7, and then if I keep scrolling down, I see 7 and 2. Remember, once I see the same numbers repeated, so 2 and 7, and then 7 and 2, I've seen everything, so you can stop looking. So 1 and 14 are definitely not going to add to give me 5. That makes no sense. That's not going to work. But 2 and 7... yes. So I need to think which one should be negative, which one should be positive. You could try both, either way, but you should come out with a negative 2 plus 7. Those will multiply to give me negative 14 and add to give me 5. Now, I'm going to take a shortcut here. And the shortcut I'm going to take is if you know your a value is 1, which in this case it is, there's a really nice shortcut that we can take. Once we know these two values, you can just use them to build your answers. So we had a negative 2, so one of our answers is x minus 2. And we had a plus 7, so the other answer is x plus 7. Okay? You can only do that. I cannot emphasize that enough. That only works if your a is 1. If your a is anything other than 1, that will not work, okay? But for the sake of time, I'm going to use that shortcut today. All right, so we've got our x minus 2, I meant to say plus, my bad, plus 7. I think I said it, and then I just wrote it wrong. Equals 0. Okay, now from here, our factoring steps tell us to set each of these parenthesis sets equal to 0 individually. So I have x minus 2 equals 0, and x plus 7 equals 0. And I want to solve these individually. I'm going to end up with 2 answers here. So let's see, I would want to add 2. So I got x equals 2. And I'd want to subtract 7, and x equals negative 7. It's okay to have 2 answers. It just means we need to check both of our answers to make sure if they both are real solutions or if maybe just one of them is a real solution. We'll start by checking this x equals 2. What I'm going to do for the x equals 2, I'm going to plug it into this whole first part, and then we'll check to see if that matches this log base 2 of 14. So let me show you how that'll look. We're going to type in this first part into the calculator, but instead of writing x, we're going to write 2 because that's the answer we're checking right now. So when I put in my log base 2 of 2 times 2 to the power of 5 to the 5th power plus 10 times 2 to the 4th power. time. And then we need to come out of that parentheses, do our subtraction, do our new log. So we're right here, log base 2 of 2 times 2 to the third power. All right, and when I simplify that, I get a decimal answer. And we're just going to check this other part to make sure it matches that decimal answer. So log base 2 of 14. And notice that I do get the same answer both times. X equals 2 does check. So I can box that one, give it a check to verify we've checked it and it works. Now, for the second one, x equals -7. So to take a little bit of a shortcut, I know that if I were to plug in the x value into this part right here for x, just in this log, and I get an error, that means the whole thing is not going to work. Okay, so I could take the time to plug in -7 just like I did for the 2 every single time for x. I can absolutely do that. But to save time, in this case, I could also just plug it in here. So that's what I'm going to try. So when I do log base 2 of 2 times -7 to the power of 3. And when I do that and I hit enter, I get error, non-real answer. So in this case, I can just stop there because I know that if I get an error there, that none of it is going to work. And if you were to type in -7 every single time you see an x again, then you would also get error, non-real answer. The point is, though, that x equals -7 is not an answer. Now, we wouldn't say no real solutions here because we do have a solution. It's just x equals 2. It's just that second answer we got is an extraneous solution. So that will happen sometimes. We've got log base 3 of 5x plus 4 equals 6. So this one is completely different from anything we've seen so far, but luckily it's not too hard. But it is a little weird because notice we've got a log base 3 over here, but no log base 3 over here. So this is a situation when you don't have a log on either side that we could just X out, like we did here and like we did on the first page. When we don't have that, that means we need to change this from log form into exponential form. Remember, we start here with our 3 and we do our little backwards C and we end there. And when we do that, we drop the word log. This base is now the base of our exponent. And the next place I hit on my little traveling backwards C is 6. So that's the 3's exponent. And when I do my equals, and then it equals where I end up, 5x plus 4. Now from here, it's just basic solving. So I would want to reduce what is 3 to the 6th power. And it is, if you were to put it in your calculator, you get 729 equals 5x plus 4. Now from here, we just use our basic solving rules. So we would subtract 4 from both sides. That would give us 725 equals 5x. And of course, we'd want to divide by 5 to get our x alone. And we get x equals 145. Notice I just switched them. That's fine. That's just a habit of mine. I like seeing the x first. And we're allowed to do that. 725 divided by 5 is 145. So now, before I box it and keep moving, I do need to check that this is a real solution. In this case, I'm going to bring out my calculator. And I'm going to type it in. So we're going to plug in our x into the original equation. So log base 3 of 5 times, it's not x now, it's 145 plus 4. And we're going to see, do we get 6? So there's nothing we need to simplify over here, it's just 6. So do we get a true statement? Yes, we do get 6. So that tells me this does work. It is a real solution. All right, here's one for you guys to try. I will post the answers in the video description below. This has been Miss Math Tutorials.